Hey guys, welcome back to another fun and exciting video from Cristando's Algebra 1 class. So in this video we're going to go over what you all saw on that team test that we took about a week ago. And this was on this tile pattern called the Aussie Fir Tree. Okay, so we can kind of see how it's laid out here with giving us stage 1. You can see there's 2. Stage 2, we start to see, the shape of a tree growing here, Stage 4. And then stage 5 is left blank with the expectation that you'll kind of find the pattern here and draw that. A fair amount drew stage 5, but I also noticed a lot of people kind of just bypass that after seeing a pattern with the table. But let's kind of see the questions that we were being asked here on this assessment. So in number 1, it said, in your own words, describe how this pattern is growing. 2, how many tiles are in stage 10? Show your work. 3, given any stage number x, can you write an equation to determine the amount of tiles? And then 4, Snooki says that exactly 274 tiles will make one of the Aussie fir trees. She's very wrong. Explain why. So, usually in these type of videos, I'll, show you guys kind of how to work out the problem, starting with the pattern, and then we'll kind of go from there and maybe write an equation. But, in this video, I've kind of decided to take a different route, and I think for this one, I want to use some student work to maybe help enlighten us on some of the different ways we could have looked at this problem. Just to be clear, I saw a lot of really good student work, a lot of different approaches to this, but I just picked one that I kind of found was across the board, really clear on how this thing was growing and how to, get an equation, how to use that equation. And at the same time, I could give some feedback on that student's work too, just some things that we can maybe improve on. So let's take a look. So here we go. The student has a really nice start where she decided to not only just count the tiles, like count 2, but to also number them, I think that that's pretty revealing as it goes down the line. So we can see that stage 2, she counts that there are 6 tiles, and then she continues numbering it this way, and then branching out with the 3, 4, 5, with that horizontal cross section, and then going down with the 6. And then with 12, she continues in that same pattern. So that 1, 2, 3, 4, 5, 6 going down, then the 7, 8, 9, 10, 11, then the 12. And then she notices, hey, like something is staying the same here. Oh, she even circles it, so she like notices that like this part is staying the same. And of course, it's still there in the next one. So that's like a really nice observation that she had. And then she continues numbering it in this way, which I think is really nice because it leads her to notice this. So she noticed that, hey, there's this thing happening where it's adding 1 in this little like middle piece each time, and then on each side that grows out, it's branching out by 1 more. And that was really clear for her from this numbering. So that was nice. So that kind of helped her just get a general sense of what was happening with this pattern, and then from there she took it to a table, which I think was a good idea. So using, this information, these numbers, she went on to fill that into a table. So let's kind of see what she did here. So here's her table. This is the other side of her paper, just zoomed in a little bit. And we could kind of see that she starts looking for the rate of change here. So she's noticing, oh, it's increasing by 4, it's increasing by 6, it's increasing by 8, it's increasing by 10, it's increasing by 12, it's increasing by 14. At this time, I think she noticed that, hey, this thing has a constant second difference where it's increasing. The rate of change itself is increasing by 2 each time. That's a really valuable thing for us to know, because once we know that something is growing by having a constant second difference, we know that the function is quadratic. That's really nice to know. And it may not be nice to know right now, but when it comes time for us to write an equation, that's really going to help us out, because we know that every quadratic equation is going to contain an x squared somewhere along the line. So she uses this table approach to go on and answer the second question. But I do want to shed some light on the first question before we talk about that. So for this one, describe how the pattern is growing. I mean, there's a lot of different ways you could write this response, but one thing I would definitely state that A, like the rate of change is definitely not constant. For sure. And again, I'm writing this in like shorthand notes just in sake of time. You'd want to answer this thing in full sentences. So that's one thing I would bring up that's definitely not constant. Maybe I would definitely want to say that it has that constant second difference, right? Definitely has a constant second difference, which will imply that it is a quadratic function. Okay, that's definitely something to notice. And then I think something else for her to put in there, because she went through all the trouble to do all this this numbering method like this, is it may have been really good for her to include that in her written statement, about, how the picture itself is growing. I think there's a lot of value in that. So I would just have like, some explanation about how the picture is growing. That would have been really nice. So let's go on and see how she went on to answer number 2. So for number 2, she was able to use that table that she had constructed, observing that second difference, to go on and go even further, all the way up to figure 10, and she just, consecutively increases the stage numbers until she gets 10, and this is all she really needed to answer that, to get 110 tiles. Okay, so that's all she really needed. 10 is close enough where it wasn't really that big of a deal, whereas if it was like, when x is 100, maybe you wouldn't want to go that route. So now, you can see that she has some work for an equation, so let's kind of talk about like how she built that equation. So now, we identified that, hey, this thing is definitely going to be quadratic, so we're definitely going to have x squared at some point. So at this time, I'd like to play Guess My Rule, and this is how I do it. Let's start at 1. You'd ask yourself, hey, what would... Well, we know we're going to square, x at some point, so hey, what is 1 squared? Well, we know 1 squared is 1. Okay, so if 1 squared is 1, what would I add to 1 to get this 2 over here? Oh, I would add 1 to that. Okay, well, let's try another one. Let's square this 2, because we know we're going to have to square x at some point. So 2 squared. Okay, 2 squared is 4, so what do I have to add to 4 to get 6? Oh, I would add 2. Okay, what about this one? I'm going to square my 3, because again, we know this thing's quadratic. 3 squared, and we know that 3 squared is 9. So the question becomes, what would I add to 9 to get 12? Oh, I'm going to add 3, again. And at this point, we should start to notice the pattern that we're squaring whatever x is, and then we're just adding whatever x is. So let's try it out with 10 and see if it works. 10 squared plus 10. Well, 10 squared is 100, plus 10 is 110, and just to confirm that, that's what the student got this way. So I think we should be pretty certain at this point that our equation is going to be squaring x, so we'll make this f of x is equal to x squared plus whatever x is. Boom. And then you got yourself your equation. One thing I would do, like she did get, this expression over here, but one suggestion for the student is it says to write an equation. That means somewhere along the line we're going to need an equal sign. So I would make this thing f of x, maybe a of x for the Aussie tree. A of x is equal to this. But we want to make sure it's an equation. Don't just leave it as an expression if they're asking you for an equation. Those are two different things. Okay? So now that we have an equation, that's going to make 4 pretty easy. As you can see, it makes 2 really easy. So let's take a look. So Snooki says there's actually 274 tiles, and that will make one of the fir trees. They're telling us that she's wrong, but they want an explanation. So the student goes on to use this expression to actually do some guess and check here. So she substitutes 16 in and gets 272, and then is able to say that she's wrong because 274 falls in the middle of 16 and 17. Now that's pretty good, and that's definitely that's a valid statement. I think one thing that would make this response a little bit stronger would to be also to tell us, like, all right, so show us this. Show us that it actually is in between there. Like that's not going to take you too long to do 17 squared plus 17, and then you could all of a sudden say, oh yeah, because stage 17 is in fact 306. So yeah, it definitely falls in between 272 and 306. There's no decimal there's no decimal stages, so it doesn't make any sense. That would be a really good description. So that's one thing I would suggest that the student do the next time you have to answer a problem like this, is go a little bit further, don't leave out those details. Don't assume that the reader or the person looking at the problem, knows that. Just another suggestion, another route you could have gone with this if you didn't want to do the guess and check. You guys all have the technology, so you could just go in here, go get yourself a nice table. Let's do x squared plus x. You went through the trouble of getting the equation, and this should match up with the table, which it does. This is what we started out with. And then, this is one way you could just go down and easily see it. So we could have answered the same question just by using this information. You'd copy down this table onto your paper, and then, write your description from here. Okay? So, again, students showed some really nice work here. It wasn't the only exemplary work. There was also some other really good stuff. If you are the student or you have similar work to the student, there's kind of my suggestions. Don't leave out these details. If it says equation, make an equal sign. Use as much evidence as you can. Go the extra mile to kind of get that. I guess the final thing I'll say to kind of conclude this video is you're going to get this back with a rubric. It's the same rubric you got back for the snake pea task. So you're graded on a couple standards that are dealing with functions. Okay, this one was pretty good. Write a function that describes the relationship between two quantities. That was writing an equation or some sort of generalization. So in order to kind of get demonstrating on this, you were going to kind of need to write some sort of equation, some sort of general rule. If you attempted, with some success to get that general rule of the equation, like you'd find yourself in approaching, but you'd also need to be able to express the growth, like how it's growing, and you'd have to show, just some understanding of how this thing was growing. As for this part, comparing and contrasting two different functions, that's not really relevant for this assessment because we were only dealing with one function. That's more for the last p-task we did. And then the other way that you were kind of assessed here was constructing viable arguments, which means really backing up your evidence with, backing up your argument with good evidence. Okay, so like you can see approaching is like, you're making some conjectures like, hey, Snooki's wrong, but you're not really showing why. You're just kind of, you have the idea, but it's not backed up by anything. Whereas if you're more in the 4 or 5 territory, that's like you're constructing a logical argument, and it's mostly supported by reasonable evidence, which this is a good example of this. Like, this is reasonable evidence of why, Now, to take this thing to maybe the 5.5 or the 6 level, you'd want to be having a little bit more evidence like this and really, really doing a good job of explaining that to the most minute detail. Okay, so that's really it. The other grade you'd be receiving on this is how your group worked together. So that you got a team grade on this. You'll also have that when you get this back. If you have any questions on this, or if you never got to take this, either leave me a comment on here, shoot me an email, or just ask me in class. And that's really it. Thank you for watching, and have a good day.